Greetings, today I'm going to be explaining how to solve simultaneous equations with each of the three different methods: substitution, elimination, and graphing. Each of these methods have their own advantages and are used interchangeably based on the equation that you are solving. For clarity, I shall be using the same equation for each method so you can compare the answers at the end, and once I have finished explaining, I will also give some practice questions for you to solve. So we're going to start off with substitution. Substitution basically works on the principle of converting one of the equations into slope-intercept form and then substituting it into the other equation by swapping it for y, and then solving for x in the equation and then finding the other variable with x by substituting it into either one of the equations. So first of all, we're going to pick one of these equations to convert into slope-intercept form. In this case, 2 is going to be the easy option, since the y coefficient is 1. So I'm going to go ahead and convert that. And this becomes 6x minus 9 equals y. So now that we know what x is, or now that we know what y is in relation to x, we can substitute 6x minus 9 into the first equation. So I'm going to write out the first equation. I'm going to swap the y for 6x minus 9. And you can see this equation now only has x coefficients and constants, and there's only one variable. So now we can solve for that variable, which is x, and find the value of x. So I'm going to simplify this equation and solve for x. And as you can see, x equals 2. So I'm going to write that number down in the corner. So once you've got your x value, we're going to substitute that into either one or both the equations to find the value of y. So I'm going to start off with this first equation here and swap x for 2. And so we've got y equals 3. I'm going to do the same thing with the second equation and see if I get the same answer. So as you can see, I've got the same answer for both the equations. So I'm going to go ahead and write y equals 3 here in the corner. So now that we have x and y values, we could substitute those into both of the equations to check if they are correct. So as I did before, I'm going to substitute it into the first equation here. And so we now know that the values work for this first equation, but this doesn't confirm that they are correct. We have to do it for both equations, since each equation on its own would theoretically have multiple values for x and y. So I'm going to go ahead and do it with the second equation here. So as you can see, the values also work for the second equation, which means that they are true. And I'm only going to go through this process of checking if the values are correct once, since I'm using the same equations for each method. And so you just have to remember that x equals 2 and y equals 3. So that is the first method, substitution. Alright, now we're moving on to the second method, elimination. Elimination is relatively harder than substitution and follows a more complex method, but it's quicker than substitution and basically works on the principle of making the two y coefficients equal, cancelling them out, and then subtracting the equations to solve for x, and then solving for y. So in order to make the y coefficients equal, we're going to multiply each equation by the other equation's y coefficient. So I'm going to multiply the first equation, for example, by 1, since the second equation's y coefficient is 1, and I'm going to multiply the second equation by 2, since the first equation's y coefficient is 2. So the first equation is going to become the same thing. It's going to be the same thing. 4x plus 2y equals 14. And then the second equation is going to become 12x minus 2y equals 18. And now, as you can see, the y coefficients are equal. So what we're going to do is we're going to cancel them out. And then we're going to subtract or add the equations. Now, the rule is that if the two signs here are different, we're going to add the equations together. So we're going to add the x coefficients and the constants. And if they're the same, we're going to subtract the equations. So if they're both plus or if they're both minus, we subtract the equations. So these two signs are different, so we're going to add the equations. So I'm going to rewrite it here as 4x equals 14 and 12x equals 18. And I'm going to add the coefficients and constants. So 12 plus 4 is 16x, and 14 plus 18 is 32. And then x is 32 divided by 16, which is x equals 2. So I'm going to write that in the corner. So now, as I did with the substitution method, I'm going to substitute 2 into both of the equations to solve for y. So I'm going to have substitute x with 2 here. And so you can see I've got y equals 3 for the first equation. I'm going to do the same thing with the second equation. So you can see I've got y equals 3 for the second equation too, which confirms it's correct. So I'm going to write this in the corner. And you can see that I've got the same x and y values as the substitution method. So now we're moving on to the final method, graphing. Graphing is the most straightforward method of them all, and unlike the algebraic method, we can find the x and y values simultaneously. And we do this by graphing each equation. So each equation will represent a line on this graph. And then we find the intersection of these two lines, and the intersection represents the x and y values that will fit both the equations to answer. So first of all, we're going to convert each equation to slope-intercept form. So I'm going to convert the first equation here into slope-intercept form. So it's going to become minus 2x plus 7 equals y. And then the second, I'm going to just erase this y here. And the second equation is going to become 6x minus 9 equals y. And now all we have to do is graph these equations and then find the intersection. So I'm going to graph the first equation here. And just as a reminder, this constant is the slope, is the y-intercept, so the intersecting the y-axis, and then the x coefficient is just the slope. So I'm going to go ahead and graph it here. Yeah, this line is a bit wonky. So now I'm going to graph the second equation. So this line here represents the second equation, and this line here represents the first equation. You can see that the lines intersect here, though the line's a bit messy, you can get the idea. The lines intersect at this point here, and the coordinates of this point are 2, 3, so the x coordinates are 2 and the x coordinates are 3, so we get x equals 2 and y equals 3, and those are the values we got before, and so these are the correct values, and this is the answer. So those are the three main methods used for solving simultaneous equations. If you want, you can go back to any of the three explanations of the methods, and I have some practice questions here if you want further practice with the simultaneous equations. And I hope you understood this video, and understand how to solve simultaneous equations. So yeah, thanks for watching.